Hello everyone and welcome to the CEM homework review video for block 4 week number 5. Today we're going over the maths homework review in this video and my name is Luke Lloyd. Let's jump into it. So here's a copy of your homework sheet. If you look here, this is the section we're on. So we're going to start off with negative numbers and then move on to some division. Both of these are in the red Bond no nonsense math book. That's the A4 book that we've used for many of these homeworks in the past and also in some of the classroom lessons. One thing I will say is they have nice little recaps for all of them, and I will throughout the lesson go through each of them in turn and show you the quick answer slides. But just one thing to draw your attention to look out for is for the division, I will go through and show us sort of the teach it right recommended method for approaching both the short and long division. And spoilers, the short answer is we just use short division for everything. And I'll go through a couple of examples of that and of course do the questions with you so you can see why we think that's slightly better for this division section. So that's something to look out for. Okay guys, let's get on with it. So here is the quick answer section. So if you want to just see the answers for negative numbers, by all means pause the video here and mark it for yourself. But if you want to see me actually complete the questions so you can work along with me, keep on watching and we'll go through. So here it is, lesson 10, negative numbers. This is the book on the right hand side here, the red no nonsense maths book. And for these, initially, we're just reordering these numbers from smallest to largest. And for this, the only hint really I would do is just make sure you cross them off as you go. So the smallest number is the most negative. Notice here, look, minus 10 is more negative than minus 5. And often if I'm thinking about this, there's a couple of ways of visualizing it. You can think about being in debt. So if you owe someone £10, you're further away from having £0 than you are than if you only owe someone 5. So owing someone a greater negative is worse, if that makes sense. Or equally, I've heard the hot and cold water idea, where if the temperature is minus 10 degrees outside, or you're going to jump into a swimming pool, you can either get into a pool with minus degrees versus 0 degrees or minus 2. Again, you'd want it to be the number to be less negative, or ideally positive, because obviously that's going to be warmer and far more appealing. So if we go through, you can see the answers. The first one have been done for you, but let's just go through. So here we have minus 18 first and foremost, then minus 15, then 2, then 5, then 20, then 33. And I can't really then make a mistake as long as I just be able to compare each number to each number. And as long as all these, as I go to the right, it gets bigger, I know I've done it correctly. So again, we've got minus 12, minus 2, 0 and 1, and then 2 and 12. Again, always read to make sure you are doing smallest first or whatever it asks. Then here, minus 54 is the most negative. Then minus 36. Then minus 28. Then minus 21. Minus 14. Minus 12. Very good. Next, E. We've got minus 14. We're looking for the largest negative to start with. Then minus 5. Minus 1. Then just double check. You've got 16, 21, and 31. Here, minus 303 is more negative than minus 300. And minus 30, minus 3, 30, and 33. And finally, minus 14, minus 7. We've got 21, 38, 61, 62. There's the answer to the first section. And again, crossing out as and when necessary. And with these, once you find the first one, you're just comparing across all of them. And it's quite easy to do it nice and quickly. These are more like the questions I think you'd find in the exam, where you're actually having to utilize these skills. So the temperature is now minus 2. It rises by 6. What's the temperature now? For these questions, I would always, what I call, translate these questions. And what does it mean to translate something? If you translate from German to French, that means change it. Well, in this case, I want you to translate these worded questions into some simple maths. So I'm going to have minus 2 rising by 6 is plus 6. So I say I've translated this wordy question into what should hopefully be a much easier maths question. And here, if I start at -2 and count up, well, -2, -1, 0. So it takes 2 to get to 0. And we have 4 left over. So the answer is 4. And with this, if we just quickly go back to our number line, if you're not very certain, you can always do these results number lines. So again, just remember that positive is this direction, negative would be this direction. So in this case, I can go 1, 2, 3, 4, 5, 6, which is how if you look as we went from -2 to -4. But again, hopefully you can do this in your head. If you can't, sketch it out to start with, and as you build up confidence, you'll be able to increase. And again, thinking about how to get to 0. So it's 2 to get to 0. So there's 4 left over. And obviously then 2 and 4 make the 6 that we moved in total. That's another nice way of sort of thinking about how we approach these questions. So hopefully you can see that there. So the temperature is -8, it rises by 8, so that's -8, add 8. And you start at -8 and go up 8, that will take you to 0. So 0 degrees. I should really write the answers in here as well. The temperature is -5. How much does it have to rise to reach 10? So slightly different question. So we're starting at -5. Well, it's going to, in order to get to 0, that's going to take 5 degrees. And then to go from 0 to 10 degrees, that's another 10 degrees. So in total, you can see that is 15 degrees. So you can see I've set this one out slightly differently, color coded differently to show it's different. But this one I've just worked out in my brain. Well, I started at -5, I had to get to 0, that took me 5 degrees, then another 10 was needed to get the last way. And you're more than welcome to set that out, and this is very similar to how I would approach sort of date and time questions, again, where you get to the nearest hour and go from there, or you get to the nearest month and go from there. Well, the same with this, is that 0 is that important point. So here we're going to translate it. The temperature is -20. How much does it rise to reach 1? Well, to go from -20 to 0 is 20 degrees, a gap of 20. And then to go from 0 to 1 is a gap of 1. So in total, it's 21 degree rise. The temperature is now 15 degrees Celsius. It rises by 7. So -15. Rising by 7 means add 7. So the temperature is now 15 add 7. Remember the way this works, because it's a negative number, the +7 moves it to the right. So it's a bit like doing 15 take 7. And again, you need to go back to here and count across. But in this case, luckily, this one's not so bad, because I think the answer is going to be -8 degrees. And again, if you weren't sure, go from -15. You could do it to 5 to get to 10, and then 2 more to get to 8. Here, temperature is -6 degrees Celsius. How much does it rise to reach 23? So to go from -6 to 0 is a gap of 6. And to get from 0 to 23 is a gap of 23. So the total difference is going to be 6 plus 23, which is 29 degrees. Which is the answer. And just remember with all of these, and again, sorry, they would all need to have degrees Celsius, degrees Celsius, degrees Celsius, degrees Celsius. And that's always worth remembering, because I know otherwise finicky math teachers will maybe try and dock you some marks. So just remember to always have your units. Okay, everyone, those are the answers. So challenge yourself question. Now, obviously for here, there's a range of answers that could be done. So for example, you might do 3 times by 7 minus 4 will get you 17. But equally, you could do 3 times 8. And then, do you see how they've added a minus? Well, that equates to minusing. So here, again, 3 times 8 is obviously 24. So you have to work out what are you going to have to subtract. So again, add minus, got to be a minus number to make it go down. If we were just adding, it would go up, which is not what we want. And it's 24 minus what to get to 17? We'll count down. 24 takes 4 away, gets you to 20, plus 3 more gets you to -17. So take away 7. And then you can actually maybe start to spot a pattern. As I increase this number by 1, we're timesing by 1 more 3, so we have to then subtract by 3 more, so this will be then -10. And and so on and so on and so on. So you could have a sequence of numbers like this. You could also have had the numbers going smaller, so 3 times 5, and then obviously that gives you 15, so you're having to then add real numbers, so you're having to add a positive 2. 3 times 4, you're going to then have to add, well, 5, because you need to get from 12 to 17. So there's sort of some example numbers you could add. Again, if you're not sure, whack them into a calculator. You can check the answers that way for whatever you put. And you could go as large as you want. You could do 3 times 100, so 300. Subtract what? And I goodness, I think 300 take away 17. So you have to take away minus 283, something like that. So you have a bit of fun with it, I think, and you'd still get the right sort of answer. So by all means, give them a check. I think we should move on now to the division. Now, with the division, obviously, here's the quick answer section, but I will also just talk through the examples because they go through an example of normal, I think call it short division, bus stop division, and then an example of long division. And I just want to show you, this is sort of the teach you right way, we would teach it in classes, how to use short division for everything. So by all means, do a quick answer here, but if you do want to just watch on to the next little bit, I'll just do a quick recap of how we divide at Teach You Right, because I think it's worth doing, and we don't really like the long division method because it takes a long time. It's no more accurate, and actually some people find it just more confusing than simple short division. So I'll show you that as well. Anyway, pause here if you just want to see the answers. Otherwise, let's crack on with it. So here is just normal division. And again, just to talk through what they've done. So obviously you've got 189 divided by 9. So you make sure that the 189 goes under the bus stop. So I'll just do my own little version here. So you have 189 under the bus stop. And then you work through. So you say, how many 9s go in 1? The answer is 0, so I recommend you write 0. You can't fit 9 people into one seat. Again, I'm always thinking about people trying to get onto a bus. But you can fit 9 people into 18 seats, and you can fit 2 lots of 9. You can fit it in twice. And finally, of course, how many 9s go into 9? 1. There's your answer. So the answer would be, well, there's your working out rather. Your answer is 21. And that's how I would go about doing it. And again, that line is to indicate done by working out. There's the answer. One thing I will say, again, less so in the 11 plus, but more in school, that technically is working out. So you would always write your answer out again. If you really wanted to show off, my old maths teacher, you'd have to underline it twice just to say, look, here's my answer, make it nice and easy for them to give you the marks. So that's your standard bog simple short division. What I want to then show you is how we do the exact same process and premise and apply it to this. Now, this method here is long division or chunking or this, that, and the other. But I want to just show you, so exactly the same question, 15 into 432 can be done in the exact same way as this question was done. So again, if you know this method and if you're already familiar with it, fine, and it works for you, good, use it. But I don't like it. It's not what I would teach. So if you can do it this way and you don't want to change because it's working, that's fine. I can totally understand not changing a math method if it works. But if you don't like this, it doesn't make sense. Instead, I recommend watch this method and see if you can use this in your classrooms and your tests because it's faster and I think it's better. So does 15 fit into 4? Well, the answer is obviously no, 0 times. So like before, we're going to carry the 4 over. So now we have 15 into 43. 15 does fit into 43, and in fact it goes in 2 times, because 2 times 15 is 30, with a remainder of 13. Now the remainder, remember, comes from the difference between 30 and 43. And the difference means take away, so if you needed to write it out, you could do 43, subtract 30. This will give you the remainder because it's the difference. So there's 13. So that 13 is what we then carry over. So we now have 15 going into 132. Now, 15 times table is not something you might practice an awful lot, and that's absolutely fine if you don't. But what I would say is, if you can practice your higher times tables, brilliant. And if you can't, don't be afraid to just simply list out your times tables. So if I couldn't work out, I think it's 8 15s going to 32, you could literally just write down off to the side, 15, add 15 is 30, add 15 is 45, 60, 75, 90, 105, 120, and then one more, which is going to take us over the top, is 135. So hopefully you can see that even if you're not able to do the times tables very easily, just by listing them out down the side, you can get to your answer quite easily. And now let's just check. How many times does 15 go into 132? Well, if you look here, the 135 is one too many, so we pick the one underneath it. So about 120 goes in, and so now it would be 1, 2, 3, 4, 5, 6, 7, 8 times. So it goes in 8 times. Now for these questions, since it's quite happy with a remainder of 12, let's just show how we get that. Again, the difference between 132 and 120, if you're not sure, you'd list it out. And the difference is 12. Again, I would hope that you could probably do most of these in your head, but that means the remainder is 12. So look, bar for a sudden change in colour, we've got exactly the same answer as we would have had, or we got for the first one, but it was easier. Certainly, I think in terms of set out, and especially if you can do these timetables in your head, it's much less working out as well. So this is how I would recommend doing this style of question. Just simply do it like a normal division, and just remember to carry over the units, and all that you will end up happening in terms of long division versus short is you might end up carrying over slightly larger numbers. So having 132 as opposed to this example where you were just sort of carrying over 1 in this case, which is not a huge amount. Right, so that's an example. That's a way of utilising the short division bus stop method to do long division questions, and it's really just sort of give you permission to say it's possible and this works, so by all means use it. Okay, so obviously, if you didn't, the quick answers, pause here and have a look at them, but otherwise let's get into it and run through the questions together. So I will just do these in front of you, and that way you can sort of hopefully see the method and follow along. I think that'll probably be the easiest way of doing it. So 2s into 5 don't go. 2 to 5. 5s into 2 don't go. 5s into 25 go 5 times. And 5s into 5 go once. 7s into 7 go once. 7s into 1 don't go, carry the 1. And then 7s into 14 go twice. 6s don't go into 3, so carry the 3. 36. 6 into 36 go 6 times. 6 into 6 go once. 4s into 6 goes 1 time, remainder 2. 4s into 24 go 6 times, and 4s into 8 go twice. 3s into 4 goes once, remainder 1. 3s into 12 go 4 times. 3s into 9 go 3 times. 5s into 1 don't go, so carry it over. 5s now into 15, again, sorry, right, 0 above. 5s into 15 go 3 times. And then here, 5s into 6 goes 1 time, remainder 1. And for these questions, you're allowed to stop there. Again, we do teach, and there's a video available, I think, on the portal, which shows you how to deal with the remainders if you want to carry on. But for now, since this is what the booklet's asked for, we'll stop there. Now, 8s into 2 don't go. Carry the 2. 8s into 24 go 3 times. 8s into 9 goes 1 time, remainder 1. 7s into 4 don't go. Carry the 4. 7s into 49 goes 7 times. And 7s into 9 goes once. Remainder 2. 4s into 3 don't go. Carry the 3. 4s into 32 do go. They go 8 times. And 4s into 8 go twice. 5s into 3 don't go. But 5s into 35 do. They go in 7 times. And 5s into 9 goes once. Remainder 4. 6s into 5 don't go. However, 6s into 54 do go. They go 9 times. And then 6s with no remainder. And then 6s into 7 goes once. Remainder 1. 2s into 1 don't go, so carry the 1. 2s into 18 go 9 times. And then 2s into 7, so 2 times 6, so it goes in 3 times. Remainder 1. 8s into 2 don't go. 8s into 24 do go 3 times. 8 into 8 go 1 times. And then 9 into 2 doesn't go. 9 into 21 does go, it goes twice. Remainder 3. And then 9 into 39 also goes. 36 times, so it goes in 4 times. And there are a difference between 36 and 39 is 3, so remainder 3. And that's the answer. answers for that section. So last bit, and perhaps this is the hardest area, so only 4 questions here, but they are slightly larger. And for these, I am going to do them in the method that I showed you earlier. So I'm going to do these all via short division. The one thing I might do, however, and you may want to do the same, is just because I like to have a bit more room, is I'm just going to rewrite my bus stop for each of them and give myself some more room. So sort of 7, 2, 5, that should be plenty. And that way, if I need to then put any numbers in the spaces, I've just got the room to do it. So, first question. 36 into 7 doesn't go. Carry the 7, so I've now got 72. 36, though, does go 2 times into 72, because double 36 is 72, so that goes in twice. And then 36 into 5 doesn't go. 0, remainder 5. So, for the first question, you can see that took almost no time at all. 36 to 725 goes in 20 times, remainder 5. That's a nice quick one to start. Next one, again, I'll do the same thing. I'll rewrite it out nice and large. So we've got 21 into 8, 4, 7, a bit more working room. 21 into 8 doesn't go, and it's never going to go when you've got a 2-digit number trying to go into a 1-digit number. But now 21 into 84 does go. In fact, it goes in 4 times, because 4 times 21 is 84, so it goes in exactly. 21 into 7 goes 0 times, so that remainder then becomes remainder 7. So the answer is 20 remainder 5, 40 remainder 7. Let's do the next one. We've got 46 into 92, or 929. 46 doesn't go into 92, it goes in 0 times. But if you double 46, you get 92. So it goes into 92 if you're going to have a carrying over. Sorry, I should have written, as people like to see it. So we're carrying the 84, we're carrying the 9 over. I've also seen people do it like this, where they sort of imply that little line to imply that it's 92 carried over. But again, it goes in twice, then it goes into 9 0 times, so then it needs to be remainder 9. So you can see how much quicker these are going than by writing out a big long method. Last one, we've got 28 into 8, 4, 3. Again, let's write this really nicely and clearly. So 28 into 8 goes 0 times. So carry the 8, so 84. 28 doubled is 56. Add an additional 28 to it and you get to 84, so it goes in 3 times. Again, if you're not sure, you may be sort of writing these out along the side. So 28, and then you've got 28 doubled, which is 56. And 56 plus 28 is 84. So that's how you can see how many times it goes in. So there you go, 3 times. And again now, 28 into 3 doesn't go, so the remainder is 3. So hopefully you can see that the answers of 20 are 5, 40 remainder 7, 20 remainder 9. So I came out a lot more quickly just using a good old-fashioned, good old-fashioned bus stop like that. 3, not a 5. And really, that's why we teach it this way. I do think it is better. So last little bit then, we just to finish off is the challenge yourself section. Here we have 5 children who went carol singing. They collected £62 and 25p and a handful of sweets. How much money did they get? How much money did they each get? So if you split it evenly. So we're going to divide this number by 5. And this is brilliant actually, because it just shows you how we would approach a decimal division. And actually the answer, nice and simple, is we would just treat it the exact same way. The only rule that matters, and you can do this at the beginning, is this decimal here should be mirrored. And as long as you're keeping your place values nice and correct, this decimal and this decimal will be in the exact same place. So then any numbers that should go above, you carry on exactly as normal, just remembering then to have that decimal there in your final answer. So in this case, 5 into 6 goes 1 time, remainder 1. 5 into then 12 goes in 2 times, remainder 2, because the difference between 10 and 12 is 2. Which leaves you now with the remainder 2. So 5s into 22 go in 4 times, remainder 2, because the difference in 20 and 22 is 2. And finally, 5s into 25 go 5 times. So again, That's our working. So my answer needs to be, remembering my units, £12.45 each. And again, if you wanted to check, I mean, you probably wouldn't do this in the exam, but you could do sort of 12 times, oh sorry, £12.45 times by 5, you end up in the same place. So remember, you can always do the reverse to check if you wanted to, but that is the answer to number A, the first one. Then for B, Jess earned £666 in 1 year doing different jobs all for her neighbours. If the doing different jobs for all her neighbours. If the money was divided equally, how much did she earn each month? So that's where we find out what we're dividing by. So we're doing this number divided by 12, so let's put that into the bus stop. Let's say I was expecting to tell us either how many jobs they did or the months in this case. So now again, we can just do it nice and simple. 12 into 6 doesn't go. But 12 into 66 does go, and that's because 12 times 5 is 60. So it goes in 5 times with a remainder of 6. And then 12 into 66, exactly the same, goes in 5 times, remainder 6. So you could either have an answer of 55, remainder 6, and that would work. But I'm not a huge fan of that for money, so I am actually just going to show you the other trick, and this will be a nice little, really nice thing to end on, of how actually, if you want to find a decimal answer, so I should make myself a bit more space, if you want to find a decimal answer, what can you do? The answer is quite interesting. So if you look here, we had 12 into this 66, which should be 266, there should be one there, one there. In fact, this is an example where I'd rather do it bigger. So let's just use my computer powers to make things a little larger. They're nice and clear. So 12 goes into 60 5 times, remainder 6. Instead of just writing R6, if I put in a decimal 0, I've not changed the number 666, that's still the same, because adding a 0.0 doesn't change it at all. But it gives me somewhere to put the remainder. So instead of having R6, I can put the remainder 6 here for 60. And what hopefully you'll notice is that 12 into 60 goes 5 times, and now there's no more remainders, so I'm done. So I could have 55 remainder 6, but I think a much clearer, much better answer is to have £55 and 50p. And so she earns £55.50 each month. And again, if you did want to just check, £55.50 times by 12 does get you to 666. So that works. But just remembering that last little trick, that if you have a remainder and you want to work out it as a decimal, just add a 0.0, because that doesn't change the number, but it gives you somewhere to put this one. If you keep getting remainders, you can keep adding as many zeros to the end as you want, as long as there's a decimal place there, it doesn't change your end answer, and you can keep putting remainders there, and you can work out some amazingly long ones. I know in class with some of my kids, we've done ones that go to 6 or 7 decimal places just to prove to ourselves that we could, and it does in fact work, and it kind of gives you real confidence. Right, everyone, really interesting challenge questions there. So those are 2 nice ones to finish on. And again, with these, don't be afraid. And honestly, just any division times any division, you can get a calculator. As long as it doesn't go on to, loads and loads of decimal places or anything, try them. You can set yourself loads of questions, and mum and dad can check them really easily by just timesing the 2 numbers together to check that it gets back to the answer you started with. So, division and multiplications are really easy to check in that way. You've got a little calculator, you've got someone to help you out. With a phone, you can try loads and loads of questions and just really quickly build up a lot of practice behind this type of question, and hopefully then feel really, really confident. Okay, everybody, thank you for that. That was obviously relatively quick. I hope it was useful, but I did think with the division, it's just worth going through the finer intricacies, because they say there are ways to speed it up and just really make yourself more productive. Right, everybody, thank you so much for your time. Thanks for watching. I hope you have a great week, and we'll see you again for more next week. Bye-bye for now.